question always becomes doing a qualitative analysis of your organic molecule in the lab is, am I really getting the compounds that these qualitative tests say I'm actually getting? Well, I thought that I would do a demonstration to show, in fact, that we can make some predictions as to the type of functional groups that we're actually making here. And since we've already done the qualitative analysis determination of the oxidation of 4-methyl-2-pentanol, which I have right here, we say that it oxidizes up to a ketone, but does it really do that? This ketone, which is 4-methyl-2-pentanone, is, as I've said, a ketone. So will it give me a 2,4-dinitrophenylhydrazine test? In fact, it's a methyl ketone, so will this also give me a test which we call the iodoform test? And I've demonstrated that with acetone. But will it work with this? This is a methyl ketone. So I thought that I would show you that, in fact, this indeed is possible to do. So what I'm going to do, first of all, is to oxidize this up with chromic acid. Now remember what I said about using chromic acid. I put this right back here. I'm going to say to myself, I have got to wear gloves for this because chromic acid is a label as a carcinogen, so we've got to take that seriously. So I'm going to put on some gloves here, and that will protect my hands. And okay, now and as I said before, when you're using chromic acid, the good thing is to not wear really good clothing, or as I'm doing, wear some sort of shield, because the sulfuric acid and chromic acid, if it gets on your clothing, is very unforgiving. You discover after you've washed your clothing that you've got these nice big holes, and my wife can attest to this over the years that I've been here. So let's just take some of the 4-methyl-2-pentanol and put about 10 drops in a test tube. We don't need very much for this because we've seen that these tests are rather sensitive. But let's 7, 8, 9, 10, 11, 12. I'm going to put about 12 drops in here. This test tube. This then should be enough to be able to conduct both the tests that I want to do. Okay, so we've got the 4-methyl-2-pentanol in here. I want to put a bit of acetone in here because, after all, this is the solvent that the oxidation is running. So I've got acetone as the solvent here. Let's put this down for a minute. Now we're going to be using chromic acid. And remember what I said about chromic acid. It's a Cr+6 compound, so that makes the reagent a very, very dark orange brown color. The chromium is in a +6 oxidation state, and that's what gives it the color. But as soon as this hits the alcohol in acetone, it turns green. Now it gets a little hot here, so what I'm going to do is to see, we've added more than enough. You can see that we've have much more chromic acid in there than we need. So let's just titrate back, and let's get this out of the way. And we're going to add a little bit more 4-methyl-2-pentanol to discharge the color and get back to that green. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. Let's say that that's enough. Okay. Still plenty hot. It's very hot, in fact. Okay. Okay, let's add a little bit more 4-methyl-2-pentanol. Okay, now it's starting to change to all green. Okay, so there we go. There's our reaction mixture. Now, what we formed, remember, is a Cr+3 ion, and this is probably chromium sulfate here, which is water soluble, but is not going to be diethyl ether soluble. So let's, okay, we don't need this anymore. Let's get rid of that. Let's get rid of that. Okay, now what we're going to do is put in some diethyl ether into this, and we're going to extract out the compound that we said we formed, namely the 4-methyl-2-pentanone from the oxidation with chromic acid. So let's get our diethyl ether out here. Now, with this diethyl ether, I'm also going to extract out a little bit of water, so there will be water in this, and I'm also going to extract out some of the acetone as well. So that's just the way things are. Let's add a bit of diethyl ether here, and we should be able to see 2 layers, and in fact I do. You probably can't. Let's put a little bit more diethyl ether in there. Okay. So we've got 2 layers in here. I'm going to now take this solution and pour it into here. Okay. And I'm going to do this again. So we're going to do 2 extractions. And that should be enough diethyl ether. Let's take this, and now I'm going to pour this into here. Like that. Okay. Now, remember, this has acetone in it. It also has a little bit of water, and it has the compound. So what we're going to do then is to wash it a couple of times with water to remove as much of the water-soluble stuff that just got mechanically carried over and was solubilized in the diethyl ether. And I have a stirring rod here to mix it up. Okay. And you'll notice, this isn't too hard to see at this point, you'll notice that there is a yellow lower layer. You see that? That's the aqueous layer. That's the water that I just added. It's not, remember, water is not very soluble in diethyl ether, so I can use the diethyl ether to extract out the organic stuff, and the water is going to then effectively wash out any water-soluble stuff that somehow got entrained in the diethyl ether. Okay, so there's our water. Let's just pour this into another container. We're going to do this a couple of times. Okay, so let's get this some water. This is not okay. Okay, do that. And now let's wash it again, okay, with some water. Okay, once again, let's mix it up and see what we get. Okay. You can see now we still have our 2 layers. The water's on the bottom. The ether is on the top. All right, let's decant this into another test tube. And now I'm going to dry it. I want to get that water out of there because I want to evaporate off the diethyl ether. Okay. Okay, so I've got, I decanted off a large amount of the diethyl ether. And now what I want to do is put some drying agent in there to get rid of the water that's in there. I have another stirring rod right here for that. Let's take some sodium sulfate. Now, sodium sulfate, remember, is a good drying agent. And let's put a little bit of sodium sulfate in there. Now, you can tell when there is a lot of water in a solution of diethyl ether when the sodium sulfate tends to cake up. Now this doesn't have too much water in it, but it does present a little bit of a stiff drying agent. So we're taking out the residual water with sodium sulfate. And the sodium sulfate clings to the test tube, and it's very heavy, so you can decant it out rather easily. I'm going to put it now into a beaker, and this beaker then is going to have this diethyl ether in it, and I'll be able to use the hood air supply to evaporate off the diethyl ether. Okay, so there we have our diethyl ether. It's a little bit yellow colored. I don't know what that might be, but let's not worry about it. Let's go over to our air supply here. Okay. Now, evaporating the diethyl ether produces a very cold medium. I mean, after all, that's what sweating does. It cools you down because the air evaporates and the area around it gets cooler. So here we have our, let me warm this up then with my hand a little bit and make it evaporate a little bit more readily. Okay. So we're getting rid of the diethyl ether here, and if there's any acetone left in the ether, that'll also be volatilized away. We don't want acetone in here, remember, because it's going to give, first of all, a positive iodoform test, and it will also give a positive 2,4-DNP test. Okay. All right, so it's not easy to see here, but we've got the what's left over from the oxidation of the 2,4 from the 4-methyl-2-pentanone. Okay, you can see it collecting along in here. You can even smell it. It smells pretty good. All right, so now we have our material in there. Let's see if it undergoes a 2,4-DNP test. Remember what that is. We take this yellow reagent. Let's bring that forward here. Take this yellow reagent and we add it directly to the compound. Let's take a look. Let's take just a couple of drops of this stuff out of here and put it in the test tube. And the result is the formation of a, in this case, it will be a yellow solid. So here's our 2,4-DNP reagent. Now let's see what we get. All right. So it's confirmed that we've actually formed a ketone because the 4-methyl-2-pentanol oxidizes up to 4-methyl-2-pentanone, which is a ketone, and a ketone is known to form a solid with the 2,4-DNP reagent. So that's the 2,4-nitrophenylhydrazone derivative of 4-methyl-2-pentanone. So we've sort of confirmed, in this case, the oxidation of 4-methyl-2-pentanol with chromic acid, because here, in fact, we formed a 2,4-dinitrophenylhydrazone solid, which is typical of a ketone. Okay, so let's put that over there. And so that makes a lot of sense. Okay. All right, let's go to the iodoform test. Once again, there's our, there isn't a whole lot of material in here. Okay, it's a very, very small amount. So let's go ahead and do that. So I'm going to take some of this out again. I'm going to put it down in here. Let's get as much as we can. Okay, there. Now remember, with the iodoform test, we use potassium iodide and iodine, and this is a very deep reddish brown liquid. Let's put just a little bit in there. We don't need too much. And if we add some sodium hydroxide to this, then hopefully we should see the yellow color of the CHI3 or iodoform. Okay. Let's bring this over here. Okay, it's starting to get that milky consistency. Okay, and you can see that there is a yellow solid that in fact is, as predicted, settling out to the bottom of the test tube. Now if we let this stand long enough, we'll be able to then actually see that yellow solid here at the bottom of the test tube. But in fact, indeed, what we've done then is to convert this material to, first of all, a ketone by the oxidation with chromic acid. And we've been able to then show that this ketone is also a methyl ketone because it gives us a positive iodoform test. So the idea that your qualitative tests indeed produce these compounds is confirmed by these further tests that you can do on the oxidation product of 4-methyl to pentanol to 4-methyl to pentanone. Let's just show you that.